Use the function below to answer questions number 1 and 2. Show any work necessary to support your answers. F of 0. What we have to do is we need to go back into the problem and decide which piece of our function to use. And in order to decide which piece of the function to use, we're going to use what I just blocked in. That's going to help us determine what we're using. So on the first one, f of 0, this is like f of x. So this is saying x is 0. Is 0 in between negative 4 and 1? Or is 0 between 1 and 7? And 0 is between negative 4 and 1, which means that we're going to use the negative 2x. And what we're going to do is we're going to take 0, and we're going to put it back into our function wherever we see x, and we get negative 2 times 0. And negative 2 times 0 is 0. And we're going to do that for all of the problems here. F of 1, we go to that blue box there, and f of 1, well, is 1 between negative 4 and 1, including both negative 4 and 1? And that is yes, it is. There's an equals. It says x is less than or equal to 1 in that top piece. So once again, we're going to use this function of negative 2x. We're going to take that value of 1. We're going to put it back into our equation wherever we see x. So we're going to put a 1 back in there. So it's negative 2 times 1 this time, and negative 2 times 1 is negative 2. F of 2. We go back to that blue box. We need to find which piece to use, and by the way, you're only going to get one answer on these. In the first part, it says that x is between negative 4 and 1, including both negative 4 and 1. And then the second piece is that x is between negative 1 and 7, including 7. Well, 2 is between 1 and 7, so we're going to use our function of x minus 6. We're going to take this value of 2, and we're going to replace the x in our function with a 2. And 2 minus 6 equals negative 4. And for our last value here, f of 6, well, we need to determine which piece to use. And 6, once again, is between 1 and 7. So we are going to use the function x minus 6. And we're going to take that value of 6 and then put it back in to a function wherever we see x. So 6 minus 6, which equals 0. Fill in the table below with the key points needed to graph f of x on the axis provided, and graph f of x using the appropriate points and arrows. Well, in this particular problem, just a reminder here that we might need all of the boxes over here, or we might not need all of the boxes. In this case, I'm going to go with we don't need all of the boxes. And what we're going to do is we're going to fill in endpoints here. So for our first piece, we're going to figure out the value for negative 4 and 1. For our second piece, we're going to figure out the value for 1 and 7. The nice part is on both of these pieces, they are segments, which answers this first question below. They are segments, and the way that we know, I'm going to write a comma there, segments, because there is a starting and ending point. But we need to go back and actually get this picture graphed. And our starting point on our first piece is at negative 4. And we're going to put negative 4 back into the function where we see x. So our actual calculation is 2 times negative 4, And I'm going to erase on my grid here in a minute, so hopefully you don't do that as well. But negative 2 times negative 4 is positive 8. And then we're going to put 1 back into our first piece. It's going to be negative 2 times 1, which is negative 2. Then we're going to our second piece. We're putting a 1 back into the function, so this is going to be 1 minus 6, which is negative 5. And then it's going to be 7 minus 6, which is 1. And the nice thing about the smartboard here is that I can erase this, because we need to graph that. We also do want to take a look at what kind of points are we going to have on here. So I want to go back up here, and it says negative 4 is less than or equal to x is less than or equal to 1. Negative 4 is less than or equal to. When we have an equal to, we're going to have a solid dot. It says x is less than or equal to 1. We're going to have a solid dot. When we switch over to the green, it says 1 is less than x is less than or equal to 7. 1 doesn't have an equal, so it's going to have an open circle. But 7 has x is less than or equal to is going to have a solid. So we come over here, and we're going to draw in our picture. Negative 4, 8. 1, negative 2. And then we've got 1, negative 5. Open circle. And 7, 1. And there's our piecewise function. We've got a couple of questions to answer here. It says, why was it necessary to find two values for x equals 1 to place on your graph? Well, x equals 1 was in both domains. And I want to go back up and show you what I was talking about. These are the domains right here. It says x is less than or equal to 1 in that top piece. It says 1 is less than x in the bottom piece. It's in both, so we need it as part of our graph for both. When we made our graph, when did we use an open dot? Well, we used an open dot when there was an equal sign. So when did we not use an open dot? Or when we used an open dot, there was no equal sign. Finally, the range. We haven't talked a lot about the range on this particular type of graph. But remember, the range goes from the lowest value on the graph to the highest value on the graph. So if we look at the green piece, that's where our lowest value is. It's at the open circle on there. And the y value of that open circle is negative 5. That's our lowest value. Our highest value is going to be on the blue part of the graph. And it's at the very top of the blue graph, that solid circle at the top, which is at 8. And remember the format, we always go this direction. But if you also remember, looking at that picture again, it's the lowest value on the green portion of our graph, which was an open circle. We're not going to have an equals here, but we are going to have an equals there with the 8, because 8 was filled in at this point.